In this video, I'm going to solve example 5 that is from textbook based on chapter quadrilateral. So what do we have to show that the bisectors of the angles of a parallelogram form a rectangle? That means, let's say first we draw a figure that is a parallelogram. Let's have drawn this a parallelogram. And say if I name this as A, B, C, D, and we are going to draw the bisectors of these angle, let's say bisector of angle A, B, and C. So first I'm going to draw the bisector of angle A, then say of B, this is for C, sorry, D, and then for C. Right. So let's say the point of intersection of these bisector start from here, say P, this being Q, so this as R, and this is S. We need to prove this figure a rectangle. So this is what you will write in the given that PQRS are the point of intersection of the internal or interior angles ABCD. And then we need to prove that this quadrilateral so formed by the bisector is a rectangle. Now, what you should know that in order to prove a quadrilateral or rectangle, we must prove these internal angles or interior angles as 90. So if you prove all these four angles as 90, we can say it is a rectangle. So let's say start with angle Q, like we are going to prove angle Q first as 90 degree. So these are bisectors here. So I can say this is angle 1 and this angle is equal. Here, these two angles are equal. Now, first I'll write that we can say that this is angle A plus angle B is equal to 180 degree. And this is because we know that adjacent angles of a parallelogram are supplementary. Now I can replace this angle A. As you can see here, angle 1 is half of angles A. So I can replace angle A with twice of angle 1, replace angle B with twice of angle 2, and that is equal to 180 degree. Now, what in case if I take 2 common from here and transpose it to the other side, it will be 180 over 2, that is 90 degree. After that, we are going to consider this triangle, that is triangle ABQ. So we'll take in triangle ABQ. We know the sum of 3 angles of a triangle is equal to 180 degrees. So I wrote this equal to 180 degree clearly by angle sum property. And then I can replace this angle 1 and 2. As you know, the value of angle 1 and 2 is 90 degree. So I can replace the sum of 1 and 2 with 90. So if I write this as 90, so we'll get 90 plus angle Q is equal to 180 degree. On transposing 180 to the other side, I'll get the value of angle Q as 90 degree. So say mark equation 1, we proved one angle is 90 degree. Now in geometry, we don't prove the same thing twice. So what we can say in the next part, we can say similarly, this angle, that is angle S, will also be 90 degree. This angle S, we can directly say it's 90 degree. That's from similarly. Similarly, I can say angle S is equal to 90 degree. But the other two angles, we cannot say similarly 90 degree. For that, I'm going to prove this angle first as 90 degree. I'll be proving this angle as 90 degree and then using vertically opposite angle, this being 90 degree. So let's say this angle is 3 and this is 4. Angle ADP is 4. Same way, here also I'm going to write angle A plus angle D, which are nothing but adjacent angles of parallelogram is 180 degree. This time, I'm going to replace angle A with twice angle 3 and angle D with twice angle 4 is equal to 180 degree. Same way here also I'm going to take 2 common and transposing it to the other side. So angle 3 plus angle 4 is equal to 180 over 2, that is 90. Now, considering this triangle, that is triangle APD, we again can say that angle 3 plus angle 4 plus this angle, that is APD, is equal to 180° by angle sum property. Like the previous way, here also angle 3 plus 4 can be replaced with its value, that is 90°. So I'm going to replace this 3 plus 4 with 90°, and this is plus angle AP. This is APD, right? Angle APD is equal to 180°. On transposing 90 to the other side, it will be 180 minus 90 as 90°. Now we have proved this angle as 90°. Now in the next part, what you can see that let's say by vertically opposite angle, right? By using vertically opposite angle, I can write this angle SPQ. This is SPQ is equal to 90°. And the reason will be as from vertically opposite angle. So we got this angle as 90, this two angles 90, and this was the third angle. Now check here, the other angle, which is the leftover, that is angle, this is SRP, SRQ is also 90°. And we can write similarly, right? So we should write the reason for writing this angle as 90°. Let's say, I should say it is similarly. So I'll write this as similarly. We can say this is 90. So this is fourth part. Now check here what we actually proved. We proved all four angles of this quadrilateral as 90. That is from 1, 2, this is 2, 3, and 4. From equation 1, 2, 3, and 4, we can say that PQRS is a rectangle, right? And the reason is here we proved each angle of this quadrilateral as 90°.